You're taking a statistics class. Grading policy says you have to get a C or better on the homework and the midterm and the final, or get a B or better on the final in order to pass. Okay? And let's suppose that you don't do any work at all, you just guess on everything. Okay? So, and you guess independently on the homework, the midterm, and the final. And let's suppose the chance that you can get a C or better on the homework by guessing is 23%. Chance you get a C or better on the midterm by guessing is 18%. And the chance you get a C or better on the final by guessing is 16%. And finally, the chance you get a B or better on the final by guessing is 5%. Okay? So first of all, can you tell from this what the chance is of getting exactly a C on the final is, rather than a C or better? Forget about plus minus. We're thinking of grade can be C, B, A. Sorry? 13? Okay. So the chance you get a C or better on the final by guessing, is 16%. The chance you get a B or better on the final by guessing is 5%. So it'd be 11%, right? Okay, you've got the event that you get a C or better, a subset of that is the event that you get a B or better, right? So the bigger thing would be C or better, the smaller is B or better. The difference is exactly a C. Yes? Okay, so you've taken the event that you get a C or better, partitioned it into two pieces. You know the probability of this, you know the probability of one of the pieces. What's left over is the probability of exactly a C. So 16% minus 5% is 11%. Okay. What's the chance that you pass the course by guessing? Guess. No. Okay, we have to, there's two ways that you can pass by guessing, right? You can either get a B or better on the final, or you can get a C or better on everything. Yes? Now, those aren't mutually exclusive the way we've said them, yes? Because if you get a C or better on everything, that includes getting a B or better on the final as one possibility. So if we want to divide and conquer, we want to break this up into pieces to find the probability, we're going to want to break it into things we can calculate the probability of separately, right? The easiest thing is going to be to break the event that you pass the course into disjoint events, each of which we can find the probability of. So we can sum the probabilities to find the overall probability. So what are the two sort of disjoint ways of passing the course by guessing? Yeah.
Getting a C or better on the homework in midterm, and getting a C on the final, or getting a B or better on the final.
Excellent. Okay, so one way to pass the class is you get a C or better on the homework, C or better on the midterm, and exactly a C on the final. Right? And another way is to get a B or better on the final, regardless of what your homework and midterm are. Now, those two ways of doing it are now disjoint, right? Because if you get a B or better on the final, you didn't get exactly a C on the final. So now we can find the probability that you pass the class by finding the probability of those two disjoint ways of doing it and adding their probabilities. So the first event we'll call A is the event that you get greater than or equal to C on homework, greater than or equal to C on midterm, and exactly a C on the final. If the chalk is particularly fragile or I'm particularly brutal on it today, but greater than or equal to B on the final. Okay, and now A intersect B is empty, they're disjoint, and A union B is all the ways that you can pass the class. Okay, so we've partitioned the event passing the class into two disjoint pieces. We can find their probabilities separately and add them to find the probability that we pass. Okay? So how about this one? The probability of that ought to be pretty easy. Yeah, it's given. It's 5%. Okay? So P of B is 5%. And what's P of A? Well, this has to happen, and this has to happen, and this has to happen, right? It's the probability of an intersection. One of the assumptions is that you're guessing independently on all these things. So the event that you get at least a C on the homework is independent of the event that you get at least a C on the midterm, and that's independent of the event that you get exactly a C on the final. So we can find the probability that this happens, and this happens, and this happens by multiplying the probabilities that they happen separately using the independence. Okay? So what's the chance you get at least a C on the homework? So that's 23%. What's the chance you get at least a C on the midterm? 18%. And what's the chance you get exactly a C on the final? Figure that that was 11%. Okay, so the probability of A using the independence is, what did we just say? It was 0.23 times 0.18 times 0.11. Okay? And so if we add 0.05 to this product, that's the chance you pass the course by guessing. Is all right? Any questions? Good? Okay. So we used independence to find the probability of intersection. We first broke things up into disjoint pieces so we could add their probabilities to find the probability that either of those things occurs.